Okay, so today we're going to look at a new type of sequences in series. We're going to look at geometric sequences in series, and today is just day 1. The difference between geometric and arithmetic sequences can be pretty obvious. Okay, geometric sequence is a sequence in which each term after the first is obtained by multiplying by a fixed non-zero real number, known as the common ratio. So if we look at this first sequence, 1, 2, 4, 8, 16. It's not going up by a constant amount, like an arithmetic. Each time we are multiplying by 2. 1 times 2 gave us 2. 2 times 2 gave us 4, and so forth. So in this sequence, our initial term, a sub 1, was 1. Our common ratio, which we denote by an r, would be 2. It's the number that we keep multiplying by. Now, maybe you don't notice it as easy in a different type of sequence. Maybe you have fractions and you can't tell what you're actually multiplying by. The formula for a common ratio is taking a term and dividing it by the previous term. So you can't start with the first term because there's nothing before that. But if I start with the second term, which is 2, divide by 1, I get 2. I could start, let's do the fifth and the fourth. Fifth term was 16. Fourth term was 8. I get 2. So as long as I take a term and divide it by the previous term, we're going to be all good there. Now, to find the nth term of geometric sequence, we have a new formula here. We have a sub n is equal to the first term times r raised to the n minus 1. So basically, how many times do I need to multiply it by that ratio to get to the term I want? So if you get this first example, find a sub 5 for a geometric sequence with the first term of negative 2, and r is 4. So if you really wanted to, okay, a sub 1 is negative 2, times by 4 would get me to the second term, times by 4 the third term, times by 4 the fourth term, times by 4 the fifth term. I could do it just this way if I wanted to. So that would give me negative 512. But if you really think about this, this goes right back to our formula. A sub 5 would equal the first term, which is negative 2, times r, which was 4, to the n minus 1. Well, in this case, since it's a sub 5, there's our n, 5 minus 1. That is negative 2 times 4 to the fourth. Now, the formula really helps us when we're dealing with a term that is, like the 90th term, or something that we don't want to just keep hitting multiply by a number on our calculator. The next one, find a sub n for the geometric sequence. So we're just trying to find our formula to help us figure out what any a sub n is. Well, right away we see we have a sub 1. We have our initial term, so a sub n will equal a sub 1 times some r that we need to find to the n minus 1. So we just need to find what this r is. And we're going to find this r by going back to the previous one, okay, our previous formula, where we're going to take one term, divide by a preceding term. So we can take negative 9/4 and divide by 3 to get r, which would be the same as multiplying by 1/3. We see r as a negative 9/12, which is a negative 3/4. Okay, so our r is negative 3/4. Okay, and that makes sense because if we notice we have that alternating pattern, so our r is a negative so that it alternates positive, negative, as we go on. Okay, next one. Find the initial term of a geometric sequence where we have the third term is 5, the eighth term is 1 over 625. There's a lot of ways to do this, okay? But biggest thing, we do need to figure out what r is. And so one way of doing this is we could kind of do a system of equations. Use our a sub n formula. So a sub 3 is 5 is equal to whatever a sub 1 is times r to the n minus 1. So 3 minus 1 is 2. And then we also would have 1 over 625 is equal to a sub 1 times r to the n minus 1. 8 minus 1 is 7. This is just one way. There are other ways you can do this. And then what we could do here is I could solve for a sub 1 in this top one. A sub 1 would equal 5 over r squared. Okay, so if I take this, I'm going to substitute that in for a sub 1. 1 over 625 equals 5 over r squared times r to the 7th. 1 over 625 equals 5r to the 5th. Divide 1 over 625 by 5. That gives me 1. Oops, sorry, this should be the 5th here, not the 2nd. 1 over 3125 is r to the 5th. We need to take the 5th root of that. So basically we're looking for what number to the 5th would give me the 3125. And that is actually 5. So r to the 5th is, so r ends up being just 1/5. Okay, so we have our r value. That's the biggest thing we need to do. And there are a lot of ways to do that. Okay, this is one of those methods. I think a lot of you guys could figure out other methods. You could even kind of do a guess and check here. Okay, now that I know my r, I got to get back to my initial term. Well, if a sub 3 is 5, if I want to get to a sub 2, normally we multiply to go forwards. We're going to divide to go backwards. So 5 divided by 1/5 is 25. And do that again. We get 1/25. So that's just one way of doing that problem. Again, you might think about this way. Oh, let's call a sub n a sub 8. My a sub 1, my initial term, we could call a sub 3. And we'd have to do that 5 times to go from 3 to the 8th. All right, so 1 over 625 equals 5r to the 5th. And now you notice we actually end up with the exact same thing we had down there. So either way to get to that is perfectly fine. You can choose however you'd like to do that. Okay, we got 2 more problems down here. Okay, finding the sum. So just like we did with arithmetic, we have a sum formula where the sum is equal to, in this case, the first term times 1 minus r to the n over 1 minus r. Biggest thing we gotta do is make sure r is not 1, because if r is 1, then we're undefined on the bottom, and that's not going to work out. Okay. And then if it was that, we're just multiplying by 1. It's just how many times are you doing that? So find the sum of the first 5 terms of the geometric sequence. If I wanted to for this one, I could just find the last term and then add them. But let's go ahead and use our formula. So we have a sub 1. So s sub 5, so that number is how many terms, is equal to 12 times 1 minus whatever r is. We got to find r. N is going to be 5 over 1 minus r. And we got to find r. So remember, r is from dividing a term by its preceding term. So negative 4 divided by 12 is r. So we get negative 1/3. Be careful with parentheses up here on top. This really just becomes plus 1/3 then on the bottom. And we can go to our calculator then for this next part. So I'll work on the inside there first. While I'm doing this, you guys should be checking that you can get this as well. You should end up getting here, the sum of the first 5 terms is 244 over 27. 244 over 27. And again, you could just find the next term, which if we multiply by negative 1/3 would become a positive 4/24 27, so you could add those. So 12 plus negative 4 plus 4 divided by 3 plus negative 4 ninths plus 4 27ths. And you find out you get the exact same thing. Okay, last one is using that sigma notation. And again, I posted links on how to use sigma notation in both the 84 and 89. So go ahead and do that. Here, what we should notice is that if I plug in a 1, okay, that's going to give you my initial term. Okay, so a sub 1 would be 4 times 5 to the first, which is 20. My last term would be the 8th term. That in this case, it doesn't really matter because I don't need the last term there. What I do need is my second term. So I can figure out what our ratio was. Okay, well that's 4 times 5 squared. 4 times 25 is 100. So R would equal 100 over 20, which is 5. Now a lot of you are like, I didn't need to do that. And you really didn't need to do that. If you notice that 4 is always there, and this is what's changing how many 5s we have, that is going to be your R. Okay. So the sum of the first 8 terms, because we've got 1, 2, 3, 4, 5, 6, 7, 8. Be careful. Sometimes people mistake how many terms there are. Is equal to the first term of 20. Again, times 1 minus R. So 5 to the number of terms 8 over 1 minus R. So we got 1 minus 5 to the 8th times 20 divided by negative 4. And we end up with a really large number here. We end up with 1,953,120. And if you think about it, these numbers do go quickly. We go 20, we go to 100, then we're going to times by 5 again. That's going to get very large on us quickly. Okay. Also get that